Okay, welcome back to another episode of Recharging the Human Battery Radio. I'm your host, Dr. Stefano Sinicropi. We are on AM 950, and it's great to be back with you, you guys today. So, let me just preface what I'm going to talk about today, because a lot of folks through social media and through private messaging have been asking me to really dive into more how advancements in Western medical technologies are intersecting with all the things that I have been talking about over the last, couple of years, which a lot of health and wellness, integrative health, newer technologies like light therapies and lasers and oxygen therapy and different supplementation and other biohacks, different dieting techniques, all kinds of stuff that we talk about, microbiome. And, it is really important when I set out on this mission to be cognizant of the fact I am a Western trained doctor. I trained at Columbia University in New York City. Really thankful to these brilliant people that I got to train under. I mean, really true giants of the game. I mean, there were people there that, should have won, multiple Nobel Prizes for some of the work they did, including, the neurology department, psychiatry, my department, orthopedics, and others. And again, I was really hardcore trained in Western medicine. So the advantage there, as far as getting into this whole new world and the way things are changing rapidly, is I'm really in tune with what is going on in the sphere of what you guys would consider traditional Western medicine. Those breaking news stories you see on the radio, things like that. But also, obviously, I'm very passionate about health and wellness and things that are outside of traditional medicine, which can make a dramatic impact in our health, such as diet and biohacking, all those things we talk about. How do we put them all together? When I launched my original podcast, Wellness at the Speed of Light, and then decided to do this show, middle of writing the book, which is now completed, it was really not about completely shifting my focus and just saying, you know what, all that stuff, it doesn't work, there's no use for it. No, absolutely not. I want to really emphasize that medications and technologies that have been developed here in these, in the United States and other westernized countries, and frankly now there's development in many different countries around the world. They have saved millions of people. They have allowed people to, keep their limbs. We've been able to cure some people of cancer, at least put them in remission for many, many years. The question is, how do you combine these, these two things? Another thing I want to say is, it's really important for those of you that are listening to understand that we are at the precipice of the greatest convergence of technology in human history, which is literally going to change everything. Our ability to develop new molecules, to develop new technologies has never been greater. Why? Because of the advent of AI. Things are getting faster. The chips are getting faster. It's unbelievable. You have these tiny little microchips that have as much power as the entire computer that landed us on the moon or got the space shuttle up, into orbit. And so we really are at the precipice. The 2020s and going into the 2030s will be the biggest change in human history. And obviously that includes medicine. So I wanted to spend the day today talking about some of the incredible advancements that have happened just in 2025. Things are progressing so rapidly, and I want to try to tie that into some of the technologies that I have become more interested in that are in the, well, I don't want to say I hate the word alternative, but are in spaces that are not, traditionally thought of. How do we combine those two things? And so there is so many exciting innovations that have come down the pipe. It's very important to keep abreast of these. Why? Because you and your family members may be suffering from some of the diseases we talk on, and the changes to how we diagnose it, to how we treat it, are going to evolve at lightning speed, and it's important to keep on top of it. So we'll see you on the other side of the break. This is Recharging the Human Battery. I'm your host, Dr. Stefano Sinicropi, on AM 950 Radio. everyone. Thanks for sticking around. We are on Recharging the Human Battery Radio. I'm your host, Dr. Stefano Sinicropi. This is AM 950 Radio, and today we're going to be talking about the pace of advancements, which honestly is moving at a speed that we never thought that this speed was possible in the way that advancements are going. And things like AI, which is proceeding at an almost, dare I say, a scary rate, are making these advancements even move faster. Now, as you guys know, one of the topics that we focus on a lot on this show is the alarming increase in chronic diseases in this country and around the world. Most of these diseases are mediated by inflammation, and they are in many ways man-made diseases. And unfortunately, our population is quite sick. Like I've said before, just as rough numbers, probably about 50% of adults have some kind of a chronic disease, and then it goes all the way to 12-15% of adults have 5 or more chronic diseases. And I tend to see a lot of these patients in my clinic as a spine surgeon, but obviously also in integrative health. But as a spine surgeon, people are getting sicker and sicker. And so I think that the best way to handle this situation, we have to understand from a fiscal standpoint, it is going to get out of control trying to manage these ballooning costs. Okay, we've gone through the numbers before, but generally our overall spend on healthcare and things related to it is over $4 trillion, and 90% of it goes to sick care. So how are we going to handle this sick care? It's really, there's 2 ways to do it. One, we have to change lifestyles, and we have to add all these biohacking, all these other things that we have made tremendous advancements on. We understand how specific diets can reverse diabetes. We understand how autoimmune disease is going to improve with specific biohacks, dieting, and other things. We're really starting to understand this as more and more studies are coming out. That is one bucket and one direction that we are going in, where can reduce costs. And I've talked about this before. Just changing the regular American diet can save $1 trillion, $2 trillion, right? Because a lot of these diseases are man-made. You start taking away chemicals in the water, microplastics, exposure to, 5G radiation, all these other things that all are all coming together to make us sick, and we can completely reverse our chronic health disease crisis, and we would be in an infinitely better position financially. But the truth is that is just one, facet of it, because, yes, it would work. I talk about it ad nauseum in my book of how we can reduce costs by doing those things. The truth is that the American public has been beyond brainwashed to believe that it's okay to, eat this way, live this way, be exposed to all these toxins, because it's slow. You're not really seeing it from day to day. It happens over a long period of time. So people don't realize it until the snowball is too far. So the truth is, even though I'm out here banging the drums, shouting from the rooftops, talking to every single person that, will listen to me about making those changes, only a subset of people are going to make those changes. So we need other tools, and we need kind of like westernized medicine to also progress, so the people that do get sick, when they get sick, our costs are reduced. And this is really the target. It's not about more drugs. It's not about more procedures. It's about drugs and procedures that reduce the cost from what we're doing now. So, for example, coming up with lower cost drugs, medications, right? Things that can be made very cheaply, can be available widely, coming up with more minimally invasive type of interventions that are going to save a lot of money on hospitalizations, are going to decrease morbidity, which is basically, having complications, being sick, and mortality, dying. And so this is really the focus. So I want to get into some of the most exciting innovations on the Western medical front, on the technology front, that are really going to change things that I've outlined. I looked at about 100 things that are going to make a huge impact. And yeah, I just said 100, and there's more than that. But I looked at 100 things and tried to narrow it down to, 10 or in the teens, and we'll see how many we can, we can get through. to make a difference. So let's start with dementia. So we've talked about this ad nauseum. Dementia is a gigantic problem. World Health Organization estimates that dementia is going to triple by the year 2050. There's going to be hundreds of millions of people suffering from dementia. What happens? They can't remember where they are. They really need a lot of care. It's massive effects on the family. Alzheimer's is devastating, and other dementias are just as devastating. And so what can we do about it? Well, very interestingly, one of the things that can make a huge impact is picking it up much earlier than it's being picked up now. And so it's extremely exciting to see that there has been a predictive diagnostic blood test that has come out by C2N Diagnostic and Swedish researchers. It costs $500. Okay, I'm going to go into it in a second. $500. It potentially can pick up you developing Alzheimer's, you or your family member developing Alzheimer's 10 years before it happens. This is so critical and so impactful. I just cannot emphasize it. Okay, so we know that there are things that alter the course of Alzheimer's disease. Now, let's go back for a second. Alzheimer's disease is now being renamed type 3 diabetes. Why? Because it has to do with insulin resistance. It is the same things that cause heart disease, that cause stroke, that cause all these other inflammatory conditions, skin conditions, whatever. They also cause, or not always, but in conjunction with your genetics and things like that, accelerate Alzheimer's disease and can actually cause it. Okay? And so if we can then pick things up earlier and we know what to do about it, what can we do? We can make dramatic lifestyle changes. So studies have already come out clearly showing that fasting can alter the course of the disease and improve cognition and things like that. So if you know 10 years earlier, maybe you're going to change your lifestyle really rapidly. Because I could tell you, if somebody told me I'm going to get Alzheimer's disease in 10 years, and I'm already living a healthy lifestyle, I would up it by another, 100% change. I would do anything in my power because that's not something we want. You do not want to experience it. I've had multiple family members have it. I had a very close aunt that I got to see deteriorate with Alzheimer's disease. It's absolutely horrific. What else can we do if we can detect it earlier? Well, guess what? We can do things like transcranial light therapy, which is showing more and more promise in actually stimulating blood flow, improving mitochondrial, dysfunction, all kinds of things that can prevent potentially or at least slow down this process as much as we can so we then can do something about it as opposed to how it's happening now, right? Grandma starts forgetting everything. She can't find her keys. She gets lost a few times. And then finally, people decide, you know what, I think this isn't good. So you go in, people get their Alzheimer's test. Lo and behold, they have Alzheimer's, but they're already in a mild to moderate state of Alzheimer's, which is a lot more difficult. Now, yes, can we change the trajectory? Yes. But how much better is it to do it, preemptively, no different than any other disease. So how does this work? You come in, you a blood sample, they spin it down, and then they're looking at this ratio of these different proteins that are associated with development of Alzheimer's disease. So this AI program then takes your ratio of these two proteins and compares it to 10,000 normal people and people that have Alzheimer's disease, and then can make a prediction on where you are headed. So this is really good. The sensitivity, in other words, it's going to pick up 90% of people that are going to have it, which surpasses clinical assessments. So clinical assessments where you're trying to figure out, is this person heading down that road? It's only 60% effective. This is dramatic. I think that this is one of the biggest studies. There's a study, it's not FDA approved yet, but in Europe, there was a study that showed a 50% lower rate of misdiagnosis of Alzheimer's disease. I'm just telling you, this is groundbreaking. Look for this to come out. FDA needs to get on its a high horse and move faster. This needs to be approved immediately. Why? Because we have ways to then preemptively try to slow down this process. This is going to make a huge impact. These are the types of things that get me really fired up. This is not some fluff thing or some one-off thing. It's going to make a massive, massive impact. So really look for that, that study to come out. I think it's going to make a massive societal impact. And we've talked about Alzheimer's so much. In fact, we had Lori LeBay, of the Alzheimer's Association on. It's heartbreaking. The stories are absolutely heartbreaking to what happens to families. Okay. Let's move on to one of my favorite technologies, and unfortunately, I would need an entire show to explain how this works. But there's something called CRISPR technology. It's this gene editing. It's called CRISPR. You can look it up. You'll get thousands of pages of information on it. But it's CRISPR-Cas9. So there's this Cas9 protein. And I believe it or not, and don't I know people are going to say, "Wow, this guy's really kind of geeking out on this stuff." But I'm not kidding. I actually have in my office a CRISPR-Cas9 photo showing it cutting DNA. So that's how exciting this is. So I've thought about this. There's a woman. Her name is Jennifer Dunda. You should absolutely look her up. She's absolutely famous. She's had all these biographies written about her. I would recommend it. She's one of the big discoverers of this technology, and it's really fascinating. All right, why am I excited about this? Like, why am I telling you? Let's go kind of more lay terms. Imagine this. Imagine a scissors. We have this scissors. And this was discovered, by the way, from like evaluating these special bacteria that live like way under the ocean. It's fascinating stuff. But scientists were able to discover these scissors, and so what we can do is we can go in and we can cut DNA at a specified location. So imagine a pair. So you know what like a gene is. So say a gene has all these, these different. That has guanine and all this. I'm not going to get into all that, but anyway, you can cut the gene, and then you can insert another gene. So insert here, and then that will act completely differently. We can fix genes, right? And so this is going to be looked at. So where is this most relevant today, and where are we going with it? So when we talk about certain diseases, and one that I'll bring up that you guys have all heard of is sickle cell disease. There's another kind of form of it. It's called beta thalassemia. Most of you have never heard of that. So let's talk sickle cell. You've heard about this a lot. There's sickle cell disease. People get really sick, and there's sickle cell trait, which you're exposed to other things. But for people that have sickle cell is a one gene mutation. Okay, that is. Okay, so you imagine you have one gene that is off. Think about this. You can go in with your scissors, you can cut that gene throughout the body, and then you can insert the right sequences, and now you have fixed that condition. How is it given? It's actually, you have to, basically do it through this kind of a retroviral thing. So you almost have to infect people with these new genes, then it cuts the gene and inserts it. I'm trying to be pretty, vague about this, but CRISPR-Cas9, it's something you could read about. There's books on it. It's very complex, but they are so excited about this. There's all kinds of books that, lay people can understand very, very well. Why is this exciting? It's exciting because, think about it, for single mutation type of disorders where it's just one gene bad, this is something that is readily now being able to be addressed. And so in sickle cell patients, when they edited the cells, and again, it's a lot of cells, and it's a very complex process of how he sort of, quote unquote, reached those cells. But the trials show 95% of some of these patients are symptom-free after 2 years. Okay, the estimated, costs is, $1 million in care, right? So you imagine a lot of people getting that technology. Now, I'm not saying it's not without side effects. We have to really be careful, okay, because if we're going in playing God and editing your genes, things can go wrong, okay? There are movies. I don't want to mention. You can think about them. There are kind of these end of the world movies where you edit the genes wrong and we turn into zombies. So we don't want to do that. But these researchers are really at the forefront, and they're doing an amazing job. And so the FDA absolutely, and I agree with this 100%. Unlike like the test for Alzheimer's disease, where I want that now. I think that these things should not be rolled out until we're 100% clear and we really understand what the side effects are, and we're not opening up Pandora's box. But it is predicted that FDA approval is coming, at least for sickle cell disease and beta thalassemia, in 2026. So this is really exciting. So look for it. CRISPR technology. Write that down. Burn it into your minds. You're going to be hearing about this so much. Now, CRISPR technology, as AI really starts to understand more complex diseases, really complex diseases that are 10 genes, let's say, that are off. Imagine being able to go in and cut all 10 genes, repair them all. Now we're healing diseases in a genetic approach. That's going to be a lot harder. AI is going to make this a lot faster. So there's a lot of exciting things coming down the road. Okay, so that's CRISPR technology. Next topic, vaccines. I'm not going to get into all the controversies on vaccines. Right now, we're like massively controversial on vaccines. I will tell you, though, that a lot of why we live longer, we're living longer is because of the development of vaccines over the last century. What was killing people in 1915? Infectious disease. The reason that we've made such progress in our life expectancy is we now are not getting a lot of these, viral diseases and other things that we vaccinate against, and we're not dying from those. The reason that life expectancy has stalled, unfortunately, is because now that we've really we have never solved that problem. But the reason why life expectancy is now plateaued is obviously because of chronic diseases and inflammation in our lifestyle. So that's the next, big frontier. But let's go backwards. Right now, there is a lot of vaccine hesitancy, and there's other things. And I just want people to understand. I talk about it a little bit in my book. So, for example, if you look at the COVID vaccine, that is an mRNA-based vaccine. It's one of the first of its kind. It has its own controversies. I'm not an expert in that, so I don't get into it. But I do think we should question everything. But I will tell you, a lot of these other vaccines that we have, the standard, pediatric vaccines against, for example, pneumococcal pneumonia in older people, these are critical. I mean, these are going to save lives. Now, how we give them, how close together, I know there's the whole autism, discussion and how many there are and how close together. I'm not an expert in that. That's not my field. I'm not it's not something that I'm going to go down. But I could tell you this, what's going to make it easier for people to take vaccines and make sure that the ones that are effective and that we're proving over and over again are better? When we don't have to inject people with it. So what's the next great technology? So topical delivery via skin bacteria. And this is really fascinating. Guess what the technology is in this? CRISPR. So they're using basically CRISPR to deliver the antigen or the part of whatever thing. So say you have a virus, there's a part on the virus or the antigen that your system recognizes. We can put that signal, like for example in COVID, it's called the spike protein, but in other things, you take little bits and pieces of the virus, we can stick it in something called staph epidermis, which is a type of bacteria that lives on the skin. It's completely harmless, benign. You have trillions of them on your skin. You can actually take those skin bacteria, quote unquote, infect them or use that CRISPR technology to put those little pieces of the whatever virus you want, put it on your skin, and guess what? Now your immune system sees all of that and then can mount the same response. So there was an interesting study where they looked at it in tetanus. Tetanus is a disease you can get when you cut yourself. That's why you need to get a tetanus shot, and you need to re-up that if you, like, for example, cut yourself on a rusty nail or something like that. You don't want to get tetanus. Not a good thing to have. But it was tremendously effective in tetanus, giving pretty much the same immunity as if you got an injection. So you could imagine for those people, there are people that won't take vaccines because they're afraid of needles. And think about how nice it is for children to basically get inoculated with a cream. So potentially in the future, you just bring your kids in, they just take a bunch of paste that is basically set up by CRISPR to have all these different antigens. You put that paste on the thing, that's it, you're done. There's your visit. In fact, we could even do home kits for everybody. If you send this home, you put the cream on, your kid's not going to get measles, mumps, or rubella. So this is the future. I think that is an exciting area to look at, again, because we have to be cognizant. Yes, there are controversies in vaccines. And again, some of it's based on science and some of it's completely made up. We got to cut through that noise. And if I become more of an expert on it, I'll start talking about it. But until I've read 5 or 6 books and know it back and forth, that's not my area to talk about. But I do know one thing. If we go away from giving those what we call the childhood vaccines completely, we're going to be in a society where we really regress because we're all getting these crazy things that we've eradicated. So let's not go back 100 years and throw away 100 years of science because of controversies over things. Again, if we want to dive into specific things saying, well, maybe this vaccine is not necessary because of this, that's different. I'll let the experts hash that out. But throwing away everything and people all of a sudden saying, well, I'm not vaccinating my kids because it's horrible for you. And there's all this. That's terrible. We're really going to start seeing all kinds of really devastating infectious diseases. So let's not go there. If you want to get somebody fired up, find an infectious disease specialist. Ask them about what's going on with people refusing to take the childhood vaccines, and you'll see people turning all kinds of different colors that maybe you've never actually witnessed before. So that'll be an interesting thing. Probably a lot of you don't know infectious disease specialists, but if you know one, I would do that. Okay, another thing. This is near and dear to my heart. I think that this is huge. Okay, I'm just bringing you the huge stuff. Remember, I reviewed over 100 of these things. I'm just trying to bring you the biggest. A pancreatic cancer blood test has been developed. Why is this hugely important? And again, it's another 5 milliliters of blood, and you can diagnose basically pancreatic cancer early. It's huge because that is one of the diseases. If you pick up pancreatic cancer late, okay, I'm going to use really late terms, it sucks. It sucks. Okay, no one is immune to, no matter how much money you have, no matter how many billions you have, okay? Do a seance, ask Steve Jobs how his money prevented him from, passing from that. I have a cousin, great guy. He passed from pancreatic cancer. I still remember the day that he called me crying, having been diagnosed with pancreatic cancer, having told he has about 2 to 3 years to live at the most, and wanting to know if there was anybody up in Minnesota that could handle his care. And, we got him, hooked up with a couple of second opinions, but unfortunately he succumbed to his disease because it was picked up too late. So what about pancreatic cancer? So when you do this blood test, this was developed at the Oregon Health and Sciences. They did the trials for it, I should say. It shows a 50% higher survival with early surgery. The amount of money that this could save the system is dramatic because pancreatic cancer is not uncommon. It's predicted that if we can pick up pancreatic cancer early, it could save about 25,000 U.S. lives yearly. And so they're using AI-based technologies and looking at some DNA sequences to really identify people that may have cancer. The interesting thing is this can pick up cancers that are about the size of a grain of rice or even smaller. And then that triggers us to do other tests. Then you can see where the cancer is. And if you have surgery early and it's only localized to a very small part of the pancreas, the survival rate is actually really good. As opposed to if it has spread more in the pancreas, the survival rate is awful. What does this mean that this is now coming? So it's projected FDA approves this about 2026. Now, let's imagine the same testing for lung cancer, The same testing for colon cancer. Yeah, there's Cologuard out there, and you can get that home test and that home kit. And I'm a massive proponent of early screening. Again, even though I talk about all this health and wellness stuff and biohacking stuff, that doesn't mean you don't screen. You don't screen for prostate cancer and colon cancer. And women need to go get their yearly pap smears and all that stuff. Breast exams, mammograms. You have to do that stuff. Even if you're a health and wellness if you're so absorbed in that world, that's great. Red light therapy is not going to prevent you from getting one of those cancers if you're not screening. So please go get screened. But anyway, what does this mean? Imagine we can get the same technology now working for all of these other cancers. Imagine picking these things up when there are just a few cells. We're going to be able to save most of these people. There's no question about it. So this is dramatic. I mean, I can see, but between understanding our lifestyles and all those other things and understanding how biohacking works and all the other stuff that we talk about, I can see that absolutely making a dramatic impact on our ability to survive for longer and have so many less people die from cancer. Now, where I caution all this is that if we keep all these people living longer, but we don't change our lifestyles and do all the things that we harp and just go crazy on week in and week out, then you know what we're going to have? We're going to have a lot of people that are older, immobile, and chronically ill, sitting around in nursing homes, in wheelchairs, staring at a wall for 30 years because we can keep you around for a hell of a long time now. So we don't want that either. So if we're going to save all these people from cancers, we absolutely have to change the way we're approaching chronic diseases so that, we're dying in our 80s and 90s and even hundreds, mobile, with our brain function, able to play with our grandchildren and great-grandchildren, having hopes and dreams and just living the best life possible, that we can. Another thing I'll really talk about is in cancer, and then I'm going to get to one more, and the other one is just huge. So stay tuned for a second. There are these cancers that we are using CAR-T therapy. This didn't just come out, but there is a type of cancer called neuroblastoma. That's the latest thing that these scientists are targeting with CAR-T therapy. I'm going to make this as simple as I can. Imagine, so T cells are part of your immune system. All right, so we have T cells and B cells and all kinds of these immune systems. Immunology, one of absolutely my favorite subjects when I was in medical school. It's amazing because we are bombarded with cancer cells daily, viruses, bacteria. Our body is fighting this stuff off 24 hours a day. It's when it can't fight it, when it goes awry, that you develop cancers and you develop, other things. So what is CAR-T therapy? CAR-T therapy is where you take out the T cells, then you give people chemotherapy to kind of even, to make them even more, make their T cells even go down more and really attack those tumors. And then you take those T cells and supercharge them to be able to find the cancer and fight the cancer, and then you reintroduce them back into the patients. In a disease called neuroblastoma, the National Cancer Institute trial actually showed 60% reduction in that particular tumor. We could talk about all kinds of tumors. CAR-T therapy is being used all over the place. That neuroblastoma is not a very popular cancer, but as we get better in these cancers, about 800 cases a year, but still, if we can tackle that and reduce their tumors by 60% and improve potentially their mortality, it's incredible. And so now think about that being used for breast cancers and colon cancers and cancer this, cancer that. And again, I want to emphasize, a lot of cancers are because of our lifestyles, our exposure to toxins, our stress, all kinds of things. But when we get them, we certainly want these types of therapies. So if you guys want to do some research, CAR-T therapy, if you have a loved one that is suffering from that, I'm sure you're going to hear about it from your oncologist because this is being done now more and more, and even in local, not want to say local, but you don't have to go to major institutes anymore. There are many, many institutes that are offering these types of therapies. And I think that cancer research is really important. Obviously, we'd like to reduce cancer altogether and not have people start getting cancer, and there's many ways to do that. We can actually do an entire show on that. including things like living fasting lifestyle. There's all kinds of stuff that we can talk about. Again, not medical advice, but if you get cancer, you want the best possible treatment, and combining that with other holistic methods that we talk about is really the way to go. Like, for example, we always talk about light therapy reducing chemotherapy symptoms dramatically. So, when you have CAR T therapy, obviously you're going to have some side effects, so then mixing it with some of the other stuff we talk about, I really think that people's quality of life is going to improve dramatically over the next 5 years. Really exciting stuff, and I think that as far as getting into more in the media and doing the radio show and the wellness at the speed of light, oh my God, the amount of materials that I have coming up for you guys over the next 5 years. I mean, I'd have to do 5 shows a week to get out the information as it comes, but we'll try to distill it down. Okay, this is like a huge one. There is a molecule. I'm just going to read it to you. It's SBI 810. I know that means nothing for you. It is a non-addictive small molecule pain medication that does not tolerate the does not attack the opioid receptor. So opioids, as you guys know, painkillers, like the traditional painkillers. You guys all watched, not everybody, but most people have watched one of the documentaries or something on the Sackler family and the disaster with OxyContin and stuff like that. That's an opioid that attacks the opioid receptors. And so things that are non-opioid receptor medications, okay, so I'll give you an example, NSAIDs, non-steroidal anti-inflammatory drugs. So, for example, ibuprofen. That is the one that people are most familiar with. Celebrex, things like that. Those are non-steroidal, so those do not attack the opioid centers. Here's the cool thing about this new molecule that is being synthesized, and the trials are being done right now at Stanford, okay? 50 million Americans are going to undergo other trials slated in 2026. It's $5 per dose. Yes, you heard me, $5 per dose. That's not the exciting part. Here's the exciting part. It's 10 times stronger than ibuprofen. 10 times stronger. So imagine a drug that is non-opioid, doesn't make you sleepy. There isn't, as far as we know yet, potential to become addicted to it, and is 10 times stronger than ibuprofen. Here's a drug that I would like in my hands today for my patients. I mean, I deal with a lot of patients that have had chronic pain. What an absolute, tool. So, again, we need to push these things. I cannot think of an area in my world as a spine surgeon that needs more work than pain management. So, molecule coming down the road, SBI 810. So what about combining that? So this is the way we need to be thinking. What about combining this molecule with, for example, green light therapy? And I told you guys about all the studies that are going on at the University of Arizona looking at green light therapy, which releases your own body's natural opioids. The ones that are not going to make you addicted are not. There's really there's no side effects to that. People just have less pain. So imagine, putting green light with these new molecules together. All of a sudden, as a medical community, we need to prescribe opioids at a dramatically reduced rate. That's going to change society. Right? How many stories are out there about, this overdose or that overdose or the other thing? Yes, I get it. A lot of those are illegal narcotics coming into our country or being synthesized here or whatever. But a lot of those patients absolutely start in the medical world. Why? Because they hurt their knee, they get started on narcotics. Next thing you know, they're addicted. The potential for these new therapeutics coming down the road, combining that with the biohacking technologies that we talk about constantly, it is a game changer, and I think over the next 5 years, it's going to change everything, and it's going to look completely different 5 years from now, than it does today. So we're getting to the break right now. A little bit out of breath. Why? Because too much excitement over all these, technologies that are coming out. I'll do a couple social media posts to go a little bit deeper into some of these, specifically, so you get some more information. But other than that, on the other side of the break, we'll try to tie this all up. I may throw in one more on the other side of the break. We are on Recharging the Human Battery Radio on AM 950. I'm your host, Dr. Stefano Sinicropi, and we will see you on the other side. All right, welcome back, everyone. We're on the other side of the break. We are on AM 950 Radio. This is Recharging the Human Battery with your favorite spine surgeon host, Dr. Stefano Sinicropi, and we have gone through a litany of really exciting, progress that is happening right now, and I could not be more excited, and I think that you guys really need to be excited. You know what I'm seeing a lot of, actually, when I go through social media, as you guys know, I'm really into health span and lifespan. And when you get into these things and you start becoming an expert in those subjects, and I'm now doing a lot of lecturing and doing the TED Talks and the podcast, all this stuff, you start getting in these circles. And it's really interesting to see, especially the longevity people. And again, I mentioned things. Imagine picking up Alzheimer's early. How much life is that going to extend? And all these different things, and all this surveillance that we could do for cancers that picks it up earlier and allows us to send longer. But anyway, in those circles, in those longevity circles, it's really, really interesting because the word is out there that people are saying that if you do anything you can today to keep yourself as healthy as possible, why? Because of the advances that are coming, and they are coming, like I said, faster than we could even keep up, we are going to be able to, number one, lead much, much healthier lives. Some of it obviously is going to take a lot of effort on our own part. Remember, be the CEO of your own health. Thanks to Margaret for that phrase that I have now kind of made part of my own. But not only that part, but we're absolutely going to be able to improve the quality of life, and some of those things that I mentioned before are going to go in that direction, like pain management and things like that. But in those longevity circles, everyone's like, you know what? If you're of a certain age, if you're not elderly today, you really need to hang on. People are like, you better start like lifestyle changes and whatever, because the potential to extend life is really coming. We're really close. AI is starting to help us understand, for example, the telomeres, which is part of this whole genetic discussion. But as they shorten, it ages us. So we are seeing age more as a disease than something that's normal. And we could debate that all day. But seriously, this is how they see it. They're like, it's the disease. It shouldn't be like this. We shouldn't be aging. If we can hang on and keep ourselves healthy enough, the technologies between AI and robotics and diagnostics and molecules that we can help to heal people, and advancements in biohack, all this stuff, should be able to start extending life into the 110s, 120s, 130s. But you got to be at least okay enough for these things. You can't be too far gone, because it's a lot easier to maintain your age and kind of slow things down than it is to reverse things. So it's really fascinating. This is just a thought that keeps recurring in these circles. So, a lot of times you might hear me and you might hear my tone, and sometimes, I'm upset or I'm kind of down because of the chronic health disease crisis and how many sick people I see, and I'm trying to do something about it. But, that's one side of me. I'm just trying to ring the alarm bells so that that we got to do something about it, and you have to be part of the solution. We all have to be part of the solution. But I want you to know that I'm extraordinarily optimistic about the future. What we already have now, the future is already here. What we are offering, for example, in our integrative health clinics, it's light years ahead of what people are getting already. But this next 5 to 10 years is absolutely going to change everything, including potentially reversing a lot of serious diseases that people have today quite rapidly, actually, as we look at it. So the future, I think, is very bright. The future for humanity is bright. So today, go out and be positive. Be there for your families. try to get everyone living healthier lifestyles. Let's hang on until this technology can really keep us going into our 120s and 130s. And on that note, our time has come to an end. This has been a wonderful episode today with you guys on Recharging the Human Battery Radio. I'm your host, Dr. Stefano Sinicropi. This is AM 950, and we'll see you guys next week for another stimulating discussion. Have a great day.